Section 3.6, triangle congruence. We're going to add two more triangle congruence shortcuts to show that triangles are congruent. The first one is called side-side-side congruence postulate, or abbreviated SSS, which basically states that if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles must be congruent. So triangle ABC has 1, 2, 3 pairs of congruent sides with the other triangle, so they must be congruent. I said A first, which connected the 1 and 3 marks. What connects the 1 and 3 marks here? R. Then I said B, which connects the 1 and 2. What connects the side marks of 1 and 2? S. And then T. Now next, this one only applies to right triangles, but be careful. Just because it's a right triangle doesn't mean it has to be this theorem. You could use side angle side with right triangles. Now, before we talk about this theorem, in a right triangle, here we go, here's a right triangle. The side that is across from the right angle is called the hypotenuse. This is the hypotenuse. It's going to be very, very important that you are able to quickly identify which side of a right triangle is the hypotenuse in future units. So it's probably in your best interest now to just, as soon as you have a right triangle in a diagram, you might want to do something like this. Oh, this side's the hypotenuse. I'm going to put a little H there to remind myself that, hey, that's the hypotenuse. Okay. Well, this triangle congruence shortcut states that if the hypotenuse, hey, here's the hypotenuse, and the other sides of a right triangle are just called the legs. So here's a leg, here's a leg, right? If the hypotenuse of one triangle is congruent to the hypotenuse of another right triangle, and they have a congruent leg, then the triangles must be congruent by hypotenuse leg, HL. So we could say that triangle ABC is congruent to triangle DEF. And again, this only applies to right triangles, but again, just because it's a right triangle does not mean it has to only be proved congruent by hypotenuse leg. You could use side angle side. Determine whether the triangles are congruent or not. If so, state which postulate or theorem you used. As a reminder, at this point, we already learned about side angle side, and we now have side 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 and hypotenuse leg. In the first diagram, these two triangles are sharing a side, so I can mark that that side equals itself from the reflexive property. And they have 3 pairs of equal sides, so yes, the triangles are congruent by side, side, side. In B, these are right triangles. It'll probably be useful to identify what the hypotenuse is. The hypotenuse is the side across from the right angle. Right off the bat, I know the hypotenuse is equal in each, and they have an equal leg. So yes, those triangles must be congruent then by hypotenuse leg. But remember, just because it's a right triangle doesn't mean you have to use hypotenuse leg. What am I talking about? Look at C. These are right triangles. Look at the hypotenuse. That's the hypotenuse. That's the hypotenuse. Did they give me that the hypotenuses are congruent? No, they didn't. So I can't use hypotenuse leg here because I don't know that the hypotenuse is congruent. However, I have 1, 2 pairs of equal sides. If only their included angles were congruent. Where are the included angles? Where those sides meet up? Those sides meet up in this corner here. Well, that's a right angle and that's a right angle. Since that angle equals that one, I know the included angles are equal and they have 2 pairs of equal sides. That is, yes, by side angle side. 2 pairs of equal sides, the angles that connect them are equal, side angle side. This one is no. While I do have 2 pairs of equal sides, the included angle is located here. That's not where my equal angle is, so that one's a no. In E, I have 1, 2 pairs of equal sides. Their included angle is here and here, and they're equal, so yes, those triangles are congruent by side angle side. Determine whether the triangles are congruent or not. If so, state the postulate you used and write a congruence statement. Well, right off the bat, I see this has a side length of 8, and this has a side length of 8, so that's one pair of equal sides. This has a side length of 9. This has a side length of 9. That's two equal sides, and they share a side in the middle. That is quite literally side, side, side. So yes, the triangles are congruent by side, side, side. So let's write our statement. The triangle on the left, I'm going to call JKL. So I started off with J, which connects the 1 and 2. What connects the 1 and 2 over here? M. That has to be first. Then I said K, which connects the 1 and 3. Connecting the 1 and 3 here is K. And then L. Now, at the bottom here, this is a straight line, meaning this is a linear pair. I've got a linear pair there at the bottom, and this is 90. Well, if you subtract 180 minus 90, that means this is also going to be 90. So that's also going to be a right angle, which means they're both right triangles. This is the hypotenuse in that triangle, and this is the hypotenuse in that triangle. I know the hypotenuse is congruent in both triangles. They also share this side here. That side has to equal itself, and that's one of the legs. So I've got two right triangles with a congruent hypotenuse and a congruent leg, so yes, they're congruent by hypotenuse leg. Now the triangle on the left, I'm going to call it NMJ. So the one on the right, I'd have to call, if I did NMJ, I'd have to do KMJ. In C, those two triangles have three pairs of congruent sides, so yes, they're congruent by side, side, side. So the triangle on the left, I'm going to call it, I don't know, PQT. If I call that one PQT, then the ordered statement, P is connecting the 2 and 3 marks, so is angle S connecting the 2 and 3 marks, that has to be first. Then I said Q, which was connecting the 1 and 2, connecting the 1 and 2 is R, and then last T. In these two triangles, I have two pairs of equal sides. Now, these are not vertical angles. We can't say they're equal. They're not quite vertical angles. I don't have a pair of equal angles. I don't have all three pairs of sides being equal. I was also not given right angles, so I don't know that they're right triangles, so I can't use hypotenuse leg. So I don't have enough information here. I can't say they're congruent. I would need more information. I don't have enough information in that diagram. In this problem, once again, we got a linear pair at the bottom. If that's 90, I can subtract from 180, and that's going to be 90. And they share a leg. But in order to use hypotenuse leg, you need to know that the hypotenuse is congruent. The hypotenuse is here and here. Are there tick marks on the sides? No. So we can't use hypotenuse leg. I don't have all three sides are equal. Can't use side, side, side. I also don't have a second pair of equal sides. I can't use side, angle, side either. So this one's no. We don't have enough information here. All right, this side is equal to itself. 7 equals 7, but does 3 equal 4? No, we don't have three pairs of equal sides. We only have two, and the third sides aren't equal, so that one is going to be a no. G, they've got one pair of equal sides, and they share a side here. But it's not side, side, side because I don't have three pairs of equal sides. It's not hypotenuse leg because I don't know that those are right triangles. They did not give me that there are right angles anywhere in that. I can't assume there are right angles. And there's no other equal angles, so it can't be side, angle, side either. So that one is no, not enough information. We just don't have enough information in that diagram. In H. Now these are right triangles, so probably my best benefit to label the hypotenuse H. And notice that the hypotenuse doesn't have a mark on it. So I cannot use hypotenuse leg to show that these triangles are congruent. However, they do have two pairs of equal sides. This side is equal to this side, and this side is equal to this side. And where do they meet up? Here and here. Are those angles congruent? Yes, they're both 90. They have two pairs of equal sides. The included angle is equal. So yes, those are congruent by side, angle, side. The top triangle I'm going to call PTQ. So if I call that one PTQ, I started off with P, which was at the end of the 1 mark. end of one mark here is S, so that has to be first. Then I said T, which was the right angle, so I'll say T next. Then R. These two triangles share a side. I can mark that side is congruent because it's a part of both triangles. Also, that is the hypotenuse of both of those right triangles. The hypotenuse is the side across from the right angle. I also have an equal leg. So yes, those triangles are congruent by HL. They're right triangles. The hypotenuse is congruent. They have a congruent leg. Must be congruent by hypotenuse leg. The triangle up top, I'll call that XYW. So I start off with X, which was the right angle. So I have to start off with the right angle on the bottom, which is Z. Then I went to Y, which was at the end of the one mark. The end of the one mark there is W. And then Y. J is not enough information. Those triangles are not congruent. I have two pairs of equal sides. I don't know the third side is equal. I don't have any right angles anywhere. Can't use HL. And I don't have an equal angle. There's no side angle side. There's no side side side. Not enough information. Now, at this point, I'd encourage you to try the proof on your own. Use what we learned in the last section to start off the proof and see if you can figure this one out on your own. When you're ready, unpause the video and see how well you did. So we always want to start off by writing the given information. We were given that KL is congruent to NL. Now, usually the diagrams aren't marked up, but they already have them marked for you. We were also given that KM is congruent to NM. That was all given to me. And don't forget that the bottom left spot is always, what am I trying to prove? I'm trying to prove that those triangles are congruent. Now let's think about this. How can we prove that triangles are congruent? Well, we've learned three different shortcuts. We've learned side angle side, side side side, and hypotenuse leg. Let's take a look at the picture. Do we have any right angles anywhere? No, we don't have any right angles anywhere. We don't know that they're right triangles, so we can't use hypotenuse leg. So I was given two pairs of equal sides. So guess what? We're already almost done. If I could show somewhere that they have an equal included angle, then I could use side angle side. Or if I could show that they have a third pair of equal sides, then I could show that they're congruent by side, side, side. Is there anything we notice in this diagram that we can mark? Well, isn't this a part of both triangles? It is. So guess what? I'm allowed to say that that side equals itself. LM must be congruent to LM by the reflexive property. And guess what? We're done our proof. We've now showed that they have three pairs of equal sides. So those triangles must be congruent by side, side, side.